Good. So you may remember yesterday I said what we're going to end up doing is breaking this thing down into its numbers that multiply together to get it, and these are all prime numbers. And then we said, all right, we're going to, for every pair of them, then one of those numbers is going to come outside. Okay? And the reason for that was we could write this as root 3 times root 5 times 5. And 5 times 5 is 25. Square root that, you get 5. So I just put the 5 out in front and left the square root 3 there. Well, the big question of the day was, how in the world do you generate these numbers? Okay? So what I'm going to do is show you how to do that in two different ways. Okay, so here's a new one. And I somehow need to generate all the numbers, all the prime numbers that multiply together to get 40. And so what I'm going to do over here is just make a list of prime numbers. One's not a prime, sorry. So 2, 3, 5, 7, 11, 13. There's actually an infinite number of prime numbers, but I'll just go that far. So I'm going to ask you, what's the lowest prime number that divides? Actually, you know what? I'm going to do the other method first. Okay? I don't like this method as much, but it works okay. Can you tell me two numbers that multiply together to get 20? 2 and 20? Okay. Now, 2 is a prime number, but 20 can be broken down further, right? What do you get? 2 and 10? Okay. Or 4 and 5, right? Either way you want to. Now, 2 is prime, but 10 can be broken down, right? Into what? 5 and 2. Okay. So now you know that 40 can be written as, root 40 can be written as 2, 2, 2, 5, because here's all the numbers at the bottom of the tree. Okay? This is a tree diagram. I don't like this method as much, but it works. So I've got 2, 2, 2, 5. Okay. The method I prefer to use, make some room back over here, is this. I start with the number 40, and I'm going to ask you, what's the lowest prime number that divides into that? 2. Okay? Now, I would make a divide symbol like this, but then I'd be going up, and pretty soon I'd be off the board, and I'm too short to reach it. So I'm going to make my divide symbol upside down and then work downward. So I'm going to divide by 2, and of course I get 20. Now, can I divide by 2 again? Yeah, so I'll do that. What do I get? 10. Can I divide by 2 again? Yeah. And I get 5. Well, 5 is prime, right? So now I got my list of numbers all right down here. Okay? I call this the ladder method instead of the tree method because it kind of looks like a ladder, but it also keeps it organized better. Okay? So now I know I've got a pair of 2s, okay? And so I'm going to have a 2 outside, and then inside I'll just multiply these back together since they didn't have a one to be paired with. So 2 root 10, and now I'm done. Okay? So let's do another one. Here's root 72. Well, I'm going to use a ladder method instead of the tree method. Does it divide by 2? Yes. Okay, you get 36. Does that divide by 2? Yeah. You get 18. That divides by 2. You get 9. Well, that doesn't divide by 2 anymore. So now go to the next prime number, which is 3. Does it divide by 3? Yeah. What do you get? 3. Okay. And so now that's prime. So I'm done. Okay. And what I like to do is instead of writing the thing out again, I just say, look, there's a pair of numbers there, and a pair of numbers there. So what's going to come outside the square root? A 2 and a 3. So multiply those together, you get 6. And then what's left over inside? 2. And we're done. Okay. So I'm going to do this one here. This one's a little bit goofy because it's got a 3 out front too, but we'll deal with that in just a second. Let's deal with the 80. It divides by 2, right? You get 40. It divides by 2 again, you get 20. It divides by 2 again, you get 10. And it divides by 2 again, and you get 5. So here's my list of numbers, all right there. Okay. So there's a 2 that's going to come out, and another 2 that's going to come out, so I'll have 4. But there's also a 3 out front already. So we'll multiply the 3 by the 2 and the other 2. That's going to get you 12 total, right? Okay. So 12, and then root what? 5. Frowning at me, Jimmy, okay? Okay. So what I do is just take the number and start breaking it down by the lowest prime number I can, and keep going until I get to a prime number. So let's take a look at another one here. Root 42. Okay. Take 42. It divides by 2, you get 21. That doesn't divide by 2 anymore. But it divides by 3, and you get 7. Are there any pairs? Nope. So this is as simplified as it gets. Fair enough? Let's see if there's another one. 484. So here we go. That'll be an ugly one. 484. It's going to divide by 2. You get 242. That divides by 2 again. You get 121. That doesn't divide by 2 anymore, does it? Okay. Does it divide by 3? No. 5? No. Shoot. Next prime number is 7. Does it divide by 7? No. Next prime number after 7 is 11. Does it divide by 11?
Yes.
Yeah, it does.
Yeah.
Yep. And you get 11. Okay. So look at that. You get a pair of 2s and a pair of 11s. So you can take a 22 out, right? 2 times 11. What's left over? Nothing. Okay. So we're done. Unless you want to write square root of 1. Technically, I suppose there's a 1 left over, but who wants to write square root of 1? Ridiculous. So we'll leave it there as 22 and be done with it. Okay. So that's how you do it. You basically just take the number and break it down as much as you can. So let me just get one that will work here. Here we go. Okay, 1,470. Good grief. Who thinks of this stuff? Well, I did. Okay, so I'm going to take 1,470. It divides by 2, right? So I get 735. Does that divide by 3? Remember the divisibility trick? Add the digits up. And that number is divisible by 3, so this main number is divided by 3. What do you get? What do you get when you divide by 3? Not 15. Here it is. 245? Okay. Is that divisible by 3 again? Not? Oh, you're right. It's not. Okay. So what do you try next? 5?
49.
Okay. You get 49. That's not divisible by 5 anymore, but it is divisible by 11. No, not by 7. Excuse me. And you get 7. Okay. So what do I have here? Pair of 7s. Okay. So 7 goes outside, and then on the inside, just multiply these numbers back together. So you get 30. And you're done. That's how it works.